Hi, everybody. Thanks for coming. You made it to the last session of the first day. Congrats. Right now, I'm the only thing that stands between you and a free party in Las Vegas. So, thanks for sticking around. So in this session, I wanted to talk about what we introduced initially last year here at MIX as Project Astoria. And it has evolved into a full product that we call now the AD.NET Data Services Framework. My name is Pablo Castro. I'm the architect of Project Astoria. And what I wanted to do today is, for those of you that haven't seen Astoria before, I wanted to describe what it is and the problem space we're tackling. And for those of you that know what Astoria is, I wanted to give you an update of where we are now, what does it look now that it has become a full-on product and is on the way of shipping soon, and drill down through the details of what we've learned since we started with the prototyping effort all the way to now that we're getting ready to have a shipping product. Just out of curiosity, how many of you know what Astoria is? Wow, a lot of people. OK, so let's get started. So for us, as in the Astoria team, MIX is a very important event. We thought about Astoria for a while, but the way Astoria worked was somewhat different from other products. We had an early idea. We thought it would be interesting. And instead of going off and build a whole product and maybe go all the way to beta and then talk about it, what we did is we built a proof of concept, a prototype, and we actually shipped it as a proof of concept in MIX07 last year. So we brought it here. We had a session about it. We got a ton of feedback. And the feedback always varies, and there's people passionate about it, both on the positive or negative side of things. But overall, we got very strong support that we should go build this thing. So now, what I'm going to talk about today is the real deal. This is not a prototype. This is built by with full standard process for building products. It has a whole QA team behind it, making sure that it actually does what we say it's supposed to do. And we're in the process of getting ready to put these bits out there in production quality for people to build production applications. We also did an interesting experiment. We called it transparent design. Basically, what we did is we came to MIX. Folks said, yeah, go ahead, build this thing. So we said we are going to start from scratch. We don't want to. The prototype is a prototype, and you focus on the scenarios. But when you have to build a real thing, you go for the details. So what we did is we said we're going to design the thing from scratch all the way. And as much as we can, we are actually going to share all of the challenges and all of the design decisions that we go make publicly. So we have a blog. There is the URL at the end of the presentation. And we post all of our design decisions and also the things that we don't know what to do about. Sometimes we post questions. Sometimes we post problems for which we don't have any answers yet. And it worked really well. We got a ton of feedback out of that as well. So what you will see today is the product as it stands today, including a ton of feedback that we got through both the initial rounds at MIX and the year-long transparent design process that we went through. So the whole point of this technology is about exchanging data on the web. And why is it that exchanging data is interesting? Is this a new problem? Is it an old problem? In practice, whatever you exchange in the web is data, be presentation information, interaction information, or actual application data. The point that changed over time, and at this point it's almost a given, but still it wasn't like that like a couple of years ago, is that the way applications use and consume data in general, particularly when they are running on the web. If you look at Ajax applications and how they compare to traditional web applications that are data-driven, traditional applications are, the common pattern is, you receive a hit, you render the stuff on the server and ship it to the client all mixed up, data and markup all together. Whereas Ajax applications, actually, script lands on the client, and then what flows between client and server is only data. So that's an interesting scenario. And you can do it from scratch, but it's a lot of work, and it's better if you have tools to do it for you. Same thing with Silverlight and Flash or any other one of these technologies. When you build your application, the application has no data in it. It's a compiled thing that you put somewhere and the browser downloads and then the client plugin executes. then what makes the application interesting is the data that you exchange between the client and the server. Sometimes it's media or sort of blob-type data, but sometimes it's structured data that you want to browse and query and navigate and so on. That's one part of the spectrum. That's data-driven applications. Then there is another thing that is all over the place these days, services. If you look at a service, an online service for other systems to consume, a service in the end is an endpoint with which you exchange data one way or the other. Some of these services are very operation-centric, and some of them are very data-centric. For those services that are data-centric, in the end, there is two parts to it. There is an interface aspect that typically is not what the company hosting the service cares about, and then there is the actual value add of the service. We want to help in that space as well and make sure that people can focus on the value add aspect of the service and let the interface be part of the infrastructure that they get from the development platform. And finally, mashups, same thing. Mashups are possible today because there's so much interesting data out there. There's nothing, strictly speaking, in the technology of mashups that wasn't there a few years ago. Sure, now we have super fancy tools to build them, like Microsoft Popfly or whatever you use out there. But the point is not so much that as it is the fact that there is so much interesting data ready to be consumed out there on the web. So all of these different scenarios hint at the same problem space. We have a lot of interesting data out there, and we want to build services that expose that data and applications that consume that data, and we wanted to make it easy to do it. So how do we build RESTful data services? So first of all, why RESTful? Why REST? Coming back to the thing I mentioned in the previous slide, you can categorize services, for the most part, in two big buckets. Generalizations are tricky, but in general, your service may be more like operations-centric or more data-centric. An operations-centric server, you can think of it like things like Live ID. Live ID is you do some form of handshake, you send some credential information, somebody does some check that you don't even understand what does, and then you get some security token back or something. So it is about the operation. And for those, there are interfaces there that already exist and they do well. The other option, the other kind of service is more along the lines of data-centric. You don't care so much about the operations, or you do care, but they need to be uniform. And what you do care about is the data that you want to exchange. And the shape of the interface and the service itself is after the data that you're exposing. So we go the REST route because of that. We want to expose data, not operations, in this particular space. So what we do is we just use HTTP. The reason for that is the web is full of things. Right? There is firewalls and proxies and security and all of these things that you don't want to reinvent. There's a lot of infrastructure already there, and you want to be able to use it. So if you're running a Silverlight thingy application, whatever is the name, I don't want to say applet, or you're running an Ajax app or something, in the end, what you know is that the thing made it to the client because there was an HTTP request that was successful. So if you count only on that, you're probably in a pretty safe spot. Also, by reusing HTTP, you get to reuse a lot of the infrastructure of the web, like caching is already invented. Even geo-distributed caching by the hand of content distribution networks is already there. So there are a lot of things like that that you get for free. The other aspect is about addressing. A very important aspect of resource-centric interfaces is how do you address the pieces of information that are interesting to a particular client or applications or data service. So in many cases, the way URLs are constructed or what they mean is unspecified for good reasons in general. Like when you want to create a very general purpose framework for these things, you don't want to over-constrain these aspects. But however, when you build a specific interface, like in this case, we want an interface for structured and semi-structured data, there is value in building a bunch of uniform and predictable patterns on top of the URL space. So that not only you can address every piece of information in your system, but you can, given enough base information, you can actually build one of these URLs, and you know that what it's going to look like and what it's going to mean to the server side. And finally, data is data. And whenever you exchange data, you use a particular representation to do so. And the same piece of information can actually be represented in different ways for different applications or different use scenarios. So we fully support the concept of multiple multiple representations of the same data, even on the same server, based on the needs of the client. And for that, also, we try not to invent anything, because again, we try to work on the web. The web is a place where the more you invent, the less likely the thing is going to work. So you want to stay with the well-established standard technologies. So for representations, we use standard HTTP content type negotiation, which is a fancy way of saying we look at the accept header on HTTP requests and act based on that. Let me just show you one or two things to turn this into concrete terms, and then I'll go back to drill down and make and formalize a little bit more these concepts. So what I have here is a pre-built service. We will talk about how to build these things and so on in a minute, but I wanted to browse through the service itself a little bit and point out a few details. First of all, I said this is just HTTP. So definitely, querying data from the browser is not a use case. It's not very interesting. It's not what you want to do. That's bad. There. Now I can't, nobody move. Everybody quiet. So definitely, there's no use case on using data from the browser, like humans are not supposed to read the angle brackets and stuff. But since we are using just HTTP and in this case XML, and particularly in this case AtomPow, to represent the data, it's an easy way to take a quick look at the data before we drill down on more real application scenarios. So what I have here is I have a couple of services. This one in particular represents a social bookmarking database. So what you have here is like users and bookmarks and tags, and you tag things in the bookmarks. And this is inspired on, so this is my favorite book on this stuff. It's called RESTful Web Services. And one of the things the book does really nice is at the end, it actually goes through a real example and exercises all of the things it's been talking about. And it uses a social bookmarking thing. So I just literally grabbed the example from there because I thought it was a very interesting exercise to say, OK, there's a canonical reference example of this thing. Can we implement it in Astoria and what it looks like? And whenever I say Astoria, I mean AD.NET Data Services. So let me walk through this a little bit, through the data that is in this service. So in this case, I have tags, users, and bookmarks. So let me drill down on users. The idea here is I have a top-level container here called users, and I can use that in the URL. So I'm going to add /users to my URL, and what I get back is a representation of a list of users. The actual representation that you're seeing here is called Atom, and it's the Atom syndication format that you probably have seen around in blogs and such. Like a lot of blog servers and blog clients or syndication clients actually use the format or understand the format. The nice thing about Atom is that it's a general purpose format, and there is a lot of client and server stacks out there that can deal with it. So it's an easy and nice way of getting interoperability. In Atom, there is sets called feeds, and then there are particular resources called entries that represent a particular, in this case, a particular record for the time being in our system. So if I expand a particular entry, what I get here is standard Atom metadata. I'll get back to it in a second. And then I have the actual content, where in this case, I have like the nickname of a user, the full name of the guy, and the email address. And I could have more information there. So there is a little bit of structured information. Also, every entry has a URL. You can see the absolute URL here and the relative URL in the edit link. What that means is I can drill down a particular entry in this case, and what I get back is that resource. I no longer have the feed around it with a set of entries, in this case users. What I have is a particular user. Also, in this case, I know that users are related to bookmarks, and I can look at it at the instance level by looking at this link element that says there is a related construct. In this case, from the content type here, I can see that there is a feed, so it's a set of entries that are related to this guy. And the URL to that related construct is /bookmarks. So from here, I can say /bookmarks, and that gives me the set of bookmarks for this particular user. And if we open a bookmark, we can see here that the bookmark is a thing that has like an ID, a URI, a description, and so on. So what I was talking about before sort of reflects here. You can see how, by looking at the instances, you can see how the URLs are built, and you can predict. If you know, say, that you have an ID of 1 for a particular user, you can build a URL that you can use to do a get operation and retrieve that resource. Also, this format is independent of the actual schema, which is the key aspect. Regardless of the schema, the patterns are the same. For example, let me change from the bookmarks thing to a more traditional sample service that is the usual sort of customers and sales orders and product catalog and browse a product catalog. So I have a sample service called AdventureWorks. This is a data service that represents the data in a bikes shop. They sell bikes. So if I go to my product catalogs, this is like /products. And what I get is a list of all of the products here. And I can collapse a bunch of them. And maybe we can drill down on one. And product has a bunch of information, like the name, the color, the cost, and so on. And similarly, I can pick a particular one, and I get that product only, and doing an HTTP GET. Or I can, for example, go to the product categories and say, this is a particular product category, in this case called mountain bikes. And from that category, if I know that there is a link to products, I can say /products, and that means give me the products for that category. So again, I'll get back to the details of the URL format in a second and formalize them. But what I wanted to highlight is the fact that there is a very uniform way of dealing with URLs. And also, if you know the URL you built, you know what to expect back. This is more than the baseline REST, the typical REST style, and arguably this constrains the applicability of the technology, but that's by design. What we do is we give up being generic, but what we gain back is being able to convey more semantics on what the URLs mean and what to expect on the payload on the way back. Let me get back to the presentation, which is actually here. So the other aspect that I didn't touch on is representations. Actually, I'm going to show you something in a second. The idea with representations is to be able to separate the data from the actual shape that you use on the wire to exchange data. Because different applications, or even the same application in different scenarios, have different needs for how the data needs to be represented. So today in Astoria, we support data services. We support Atom, which is an industry standard format. We also support JSON, which stands for JavaScript Object Notation, which is very handy when you're working in a JavaScript environment like the web browser. And we are also looking at doing we'll call it plain XML, meaning just XML with the data and no GUI around it. It's not there in these bits, but we're considering doing it for V1. Let me show you what changing content type looks like real quick. So we'll grab, say, a product. Why not? And if I go here, so I have this little tool here called Fiddler. I'm sure a lot of you guys know it. It's an HTTP debugging tool, very handy. And it will allow me to show you things that I can actually not do with the browser. So I'm going to paste the URL I was using a second ago. And maybe let's focus on a particular category object. So if I do a get of this thing, what we get back, let me switch to the raw view, is a bunch of XML. An Atom representation, which is what we were looking at in the browser a second ago. So let's say I want to get JSON out of this thing. What I'll do is I'll include an HTTP header called accept, which is a standard header that clients use to communicate to servers what MIME types they understand. And in this case, I'm going to say application/JSON, indicating to the server that I would prefer the representation to be JSON. If I do another get, and now look at the raw output, JSON is not the nicest thing to read, but this GUI here, plenty of curly braces and stuff, is actually the JSON representation of the same resource that we had in Atom representation a second ago. So the idea is data is independent from the representation, and representation is an application's choice. Now, once you have a RESTful interface, the interface itself conveys a lot of or implies a lot of the typical semantics you would expect from these services, mostly because you're just going by using HTTP, and HTTP already has a set of assumptions around what the verbs mean and what the URLs mean and so on. Not the actual syntax of the URL, but what are you expected to get when you say get and put a URL in it and so on. So what we do is we follow those semantics, and we add on top like specifics that allows you to know what a URL is going to do when you perform certain operation in it, and understand the shapes of the entities that you get back. So In order to do that, we need a unified way of representing all data that we expose. So then we can explain it in the same terms. In order to do that, what we do is we have a model called the entity data model. We didn't invent it, we picked it up. And the short story of the entity data model is it's an entity relationship model that has entities and associations. An entity is like a structure with a key in it, so you can point to an entity always. An association is something that links two entities together. This maps great to the web because you can turn entities into resources. This is your unit of addressing. And then you turn associations into links, which allows you to cross-link the various entities in your system. So in this way, a data service becomes a connected graph of resources or entities that you can navigate and relate to each other and so on. So once you have a model, you can more accurately define the semantics of the operations on that model. What we do is we use regular HTTP methods, and when you do HTTP GET, what we do is we consider it a retrieval operation. So we'll give you a resource that the URL is addressing, which may be a particular entity or a resource, which in the example we saw before would be an atom entry. Say, for example, a product or a category or a bookmark. You can also get a set. You can say, give me all of the bookmarks for this user. When you say, /users1/bookmarks, we're going to give you a set. So resources sometimes are single things and sometimes are compound things. You also need to be able to modify the information there. And for that, we map the rest of the verbs to pretty much the standard mapping that exists out there. When you do a post to a container, you create a new entry within that container. When you do put, it means update the value with this new value. And when you do delete, it means eliminate this resource from the service. And of course, all of these operations are constrained by the underlying model, meaning it doesn't necessarily mean you can delete anything or you can modify anything or create something anywhere. Like each particular model will constrain what are the particular operations that make sense for a particular endpoint. Let me illustrate a couple of these points. So first of all, if you look at any of these entries, in this case we have a product, which should do OK. If we open a product, there's all of the content part we talked about before. But also, we have links. And links is the particular, in this case, atom representation for this thing. But in different representations, we have the same construct represented differently. In the end, we heavily rely on links to relate entities. In this case, we have two related links. One that associates the product with the product category it belongs to, and another one that associates the product with all of the sales orders in this case that happen to have an order line with this particular product. What that means is now we know about the associations because we understand the metadata of them, and based on that information, we can convey that in the instances. So client agents can navigate that, can traverse that link between one of the entries and the associated entry. That's why here I can say, for example, product categories 5 and then /products. The /products is literally traversing the link between a category and a product. And similarly, I could say 771, which was this particular guy, and say sales orders details. And I actually don't know if this says order detail. I don't know if this particular guy happens to have, of course, I picked the one that doesn't have any, let's say category, which should have something. And when I say /category, I traverse from the product to the category, and I can see that the category here is mountain bikes. So you can see associations going throughout the system as links. And this applies to the read case, as I showed here, and also to the update case. When we do updates, we express updates in terms of what do you want to change on an entity or a resource, and how do you want to change the way resources are linked together. Let's take a quick look at that. So let's create a new request. And in this case, let's start with the simplest resource that we have, that is the category object. The category object has one interesting field, the name. And so arguably, it's not that interesting, but it makes the example go really fast. So now I want to post a new entity. So what I'll do is I'll indicate the server how to interpret what I'm sending. But to do that, I'll use the content type header. And I'll say it's JSON. I'll use the JSON format. It's a little bit more compact. And here, I'm going to say post. So I'll post into the container to create a new category object. So the JSON payload is a collection of of names. It's a nested collection of names and values. And in this case, I have only one interesting field that I want to set, which is the name of the category. And we're going to call this the mix demo category. And I'm going to leave everything else blank, so that's all I need to do. When I execute a post, I get back at 201, which means created. And if I look at the payload, the system replays the entity for me, or the resource, but it's in a complete way. Like, for example, in this case, there is a system-assigned category ID that now I can see on the way back to the client. So like a client system can use it for something. I also get a location header that indicates where in the URL space the resource that was just created lives, so I can like act upon it later on. Let's create a little bit more complicated example. So let's say we want to create a product. So we're going to talk about the /products container. I want to add a product to my product catalog. So similarly, I'll go here. This is also a JSON payload. This is the mix product. And the product has a list price. So we'll go 1, 2, 3 for that. It has a color, let's say red. And it also has a category. So products live on a particular category. Now, the category is another resource, and we're going to take one of the categories that we already have. So the way we do that is we actually use links. So here, I have a member called category. And what I'll say is, so JSON has no namespaces, so there's no way of controlling control information. So basically, we have a magic goo called __ metadata that lets us get away with a little bit of it. So the one piece of metadata I want to give the system is what is the URI, or the URL, of the category I want to link to this guy. So I'm going to say URI, and here put categories, actually product categories. And I know the category 5 exists, so I'm going to use that one. So that's what my product looks like, a few scalar fields and a link that points to something else. When I do a post of this guy, I get another created, and I get the payload back just like before. But now, if I browse here, let me go to the product. Actually, product category 5. Look, I actually didn't plan for this. So let me refresh this. And if I go all the way down, I'm assuming it's like the last one. So there is a mixed product that is underneath category 5. And in fact, I'm going the other way here. I didn't go from the product to the category. Instead, I went from the category to the product, and I still found the thing there. So what I wanted to highlight is, first, the REST model extends well beyond just retrieving information in this case. Data services that are REST-based, based on the data services framework, actually have full update semantics. And those update semantics are not just about the values, but it's also about the linking between the resources in my system, which is very often a lot of the interesting part of information, how things relate to each other. OK, so now that we've sort of set the basics, let me formalize a little bit the URL syntax that I've been hand-waving over. And when we started to talk about Astoria, we knew that whenever you pick a format, like a URL format or something like that is very visible, it's very controversial. Everybody hates you no matter what you pick, so you can't win. So we had a format. We got a lot of feedback. We took a lot of it, so we changed a large number of things. And right now, we're more or less settled on this. We'll listen to everybody, and I'm sure people will be passionate about this. At some point, we have to stop churning the formats. This one is pretty good. You'll go through it. I wonder what your feedback is after the session. So what do URLs mean? Every service has a set of top-level containers. Like so far, we've been playing with products or product categories or bookmarks and users. So whenever you start right after the service entry point, what you put there is / and the name of an entity container, or we call it an entity set. So whenever you're working with a set, no matter how you landed on one, you can use parentheses to pick a particular element out of the set. We said before that these resources are entities, and every entity has a key. That means that we can always point to a particular entity in the system. So the thing that you see in parentheses is the value or the set of values that represents the key for a particular entity. That allows you to address a particular entity in a set, and also not only to retrieve it, but also to modify it. So if you do a put, for example, in the second line from the top, bookmarks, parentheses 1, 2, 3, what you do is you can replace the value. Or if you do an HTTP delete, you can try to delete the value that sits there. The other thing that you can do is you can traverse through members that may be scalar members or links. You saw me before saying /products, /categories, or things like that. Whenever you say /something off of a particular entry, what it means is I want to access that particular member. Sometimes the member is a scalar, and you get the value of the member. And sometimes the member is a set, and what you get, or a link, rather. And what you get is you deref the link. This is much easier by example. So let's pick a particular product. So we'll go products. We'll pick, I'm sure I'm going to pick the worst one. It's not going to have good data in it and all that. So let's say this guy. So once I have a particular product, one thing I can do is I can say / and put a member name. Like here I said /name. And what that gives me is it gives me the name, only the name with markup around. So it's only that property. You can do a put and replace the value of the thing as well. The other thing you can do is you can say category, which we now know the category is actually a link. So when you mention a link there, what we do is we dereference the link. So it is a link traversal operator. But in the end, it's also a member. So this is a very nice uniform member access operation that sometimes yields a scalar, sometimes yields the thing on the other end, which may be a scalar, not a scalar, sorry, a singleton, like in this case, or it may be a set of related things, like in the opposite direction, for example, if you have categories and you talk about the products collection. The other interesting thing is, let's take the name again. So this addressing still gives you a bunch of XML goo around it, or markup to make it sound more important. So oftentimes, once you go all the way to a particular member, very rarely you want the goo around it. So we have a little operator that's called $value. That means, don't give me the goo. I just want the value. And that you can append to anything that is a terminal thing. You cannot say $value on an entity because we don't know what is a raw value of a whole thing. But whenever you're addressing something that it doesn't have further structure that we know about, $value gives you the raw piece of information without the thing around it. I'm going to get back to this later because it has some interesting applications. The other thing that I didn't touch on is, so far I did the addressing part. How do you point to a particular resource? Now, in practice, when you're building an application, you just don't point to resources, particularly when resources consist of large sets of things. You usually want to present this information, and to do that, you subset the content, you sort it, you probably have to page over it, and so on. So you basically do a number of presentation-related operations on top of the data before you actually present it. Since that's so common, what we did is we built a set of operators right in the URL format. So I'm going to work on products, but this applies to any set, regardless of whether it is a top-level set or a set that you landed through link traversal. So a few things that are interesting to do. One is you may want to filter. So I'm going to say filter color equals red. Oops. Or translated, there is a $ filter thing, and it's tiny there. So let me put it in here. At least I have a bigger font. There is a well-known query string called $filter, and we use $ so we don't take your names. Basically, you can use any names without $. We use all the names with $. So filter takes a little expression that has to yield like a Boolean condition, whether or not something meets the condition. In this case, I'm saying whether the color is red. And we use EQ because things like, the equal symbol or greater than, all of these things cause a bunch of trouble, and it's very hard to test these systems. In real programs, you have to URL escape this anyway, so it doesn't matter. But when you're trying to learn what a system looks like, you want to be able to type a URL and get something back. So we try to make that easy. So when you get one of these guys, let me go back to IE now. What you get is all of the red ones. So the way I can show this is, I don't know, we'll do by sampling. Let's open one here. Of course, the first one is going to be red. Color, red. So there's a bunch of these guys, all red. So the other thing that you want to do, typically, in addition to filter, is you want to sort stuff. You can say, well, I want to filter by red, and by the way, just sort them by least price. What that means in this case is from smallest to biggest, and you can go the other way around and sort them from biggest to smaller. So we have a little syntax to say, give me the list of fields that you want to sort by. So you can have one or multiple fields, and then you can say ascending or descending on each one of them. And the other construct that I wanted to bring up, let me switch back to this guy has bigger fonts. So we said we can say order by. The other construct is paging. Every time you exchange data over the web, you never want the whole thing. It's too expensive, it costs bandwidth. Very rarely you want all of the information, especially a big service that has a lot of information in it. So we have a set of paging constructs. The way you do paging is we have two operators. There is a top operator that says how many rows you want at maximum. And then there is a skip operator that lets you say how much you have to skip before you get the rows. So if I just say top 2, and I'm going to switch back to IE to actually show the set. It's easier because this guy can collapse the stuff. If I say, for example, top 2, and then I collapse the entries, I get 1, 2 entries. And let's look at the first entry. It's 680, the ID, okay? Now, top 2 only lets me chop the rest of or the trailing part of the result set. But what if I want to page? Well, usually paging means first I'll get the first 2, if I'm paging in pages of 2. And then I want to skip 2 and get 2, and then skip 4 and get 2, and so on. So I can do that by here saying, well, I want to skip 4 and get 2. That will give me the third page in 2 row pages. And I don't know. Well, you have to believe me. It's a different ID, so probably it's the third page. Who knows? So finally, so far we talked about you can sort, you can filter, and you can do paging over it. The last operator that is interesting is whenever you're building these applications, very rarely you want a product or a bookmark or something like that. You tend to grab a bunch of information, enough to paint a whole screen. Paint, whatever that means in the HTML world. So we have an operator that allows you to paint a subset of the graph that you want to bring down in a single operation from the server to the client. So in this case, let's say we have product categories 5, which we've been talking about before. And so the category has the data for the category, and then it has a related link, which is the products for that category. And let's say we're painting a screen, and so we want to show the category information at the top, and then the list of products for that category. So when we're doing the HTTP GET for this first URL, we know that the first thing we're going to do is turn back and get the second one. And even with all of the HTTP optimizations for that, it's another round trip, and you want to avoid round trips. So we have this construct called expand, which what it allows you to do is you can say expand and include a property name there, just like the ones you would reference on the slash. Only it has to be a link. And what it means is give me the link in line. Just resolve it for me on the server and bring me the whole thing down. So for example, I'm going to use the products property of the category. What this does is it still brings me the category. Let me collapse this for the time being. Brings me the category just like it did before. But now the link object, or the link, element for products now has content in it. It's not empty anymore. And the content is the inline representation of what I would have gotten if I do a get over that URL separately. So the nice thing about this is you can keep going down. You can say, well, for products, also give me the sales order detail for that product that, if you remember, was all of the sales orders referencing that product. You can keep going down, and you can also go wide. You can say, navigate this link and this other link and this other link. So given an anchor point, you can describe the graph that you want to retrieve through the links in a single HTTP interaction between the client and the server. And of course, this works regardless of the format. In the Atom representation, these are links. In the JSON representation, for example, this is a property that has a singleton or an array inside it with the actual values. Let me get back here. So we went a little bit through the top ones, which are about addressing, and the bottom ones, which are mostly around presentation options that allows you to build applications. So why is this so interesting? And why I keep saying about the uniform thing of it? Uniformity in these things are important because it allows you to build frameworks and client applications and tools that can leverage this over and over again once you know the patterns of the format. Actually, let me switch back. I want to show you one more thing. So for example, I have a little thing here. It's not very fancy. It's just a small, like Ajax-y grid object that right now is pointing to the tags of the bookmarks database that we saw before. So you can hover over it, you can do like next, and it goes to the next page. You can sort by name, ascending or descending, and so on. Now, the important thing is there's very little information in this grid that you have to specify. You can specify more if you want, but let me tweak the code here a little bit. Let's make this disappear. So now I'm pointing to the bookmarks service, and I'll talk about how to build one of these things in a second, and I'm talking to the /tags URL. I could say, well, actually, don't talk to the tags URL, talk to the bookmarks URL, or entry point. And if I hit F5 in the browser, I get sort of a set of bookmarks. And I get the actual bookmarks, I get links, I can navigate inside the links, and so on. And of course, I preserve all of the sort of sorting and paging, like I can go to the next page, and so on. And so it's like the same piece of software will deal with pretty much every schema that follows the same pattern. In fact, I can switch sort of databases altogether. Like if we go to AdventureWorks, which is the one we were using so far, and let's point to product categories, and refresh here, then what you get here is the categories, and we can go through the pages, sort by the name of the thing, or sort by the product category, and so on. So the value proposition of having a very uniform URL interface as well as a format interface is that now then you can build these tools that leverage this and are reusable across different services and across problem spaces, as long as they are representable with the same class of RESTful data services. Okay, so far we talked about what these things look like. But I didn't say how to build one of these, where the data is coming from. Like I skipped over all of the details. And so now is where we get down to the details. So how do you create one of these things? Well, it actually depends on what you're trying to do. So in a lot of cases, the data that you have lives in a database. Now, I work in the SQL Server building, so I kind of assume that that's most of the time. But I actually think it's far from the majority of the times. Probably most of the time the data is in some random crazy format or repository or server, or it's out there in the cloud, and it's never exactly in the shape that you want. So the way we layered the system is we said, if this data is in a database, there's a lot of assumptions that we can make, and there's a lot of tools that we can leverage. So whenever you have a relational database system that you want to target, and we like SQL Server better, but if you have other servers, they also work, you can use the ADO.NET Entity Framework, which is a powerful sort of conceptual modeling runtime that allows you to view data in terms of a conceptual model, which happens to be the same model, it's the entity data model. So you can use the entity framework and target a database. And in fact, that's what I've been doing so far, and I'll create a new one this way in a minute. But that's far from the complete picture. The reality is that data these days is in XML files, or in the cloud, in some Facebook service, or in so many different shapes and forms out there that we cannot assume a particular one. So when you cannot assume anything about the data, it's very tricky to build an interface to actually pull the data into the system. So what we did is we leveraged this technology we shipped in Visual Studio 2008 called LINQ, or Language Integrated Query. LINQ does a lot of things. It has a language integration story that is very nice, and it lets you write queries in C# or Visual Basic and so on. But also, it defines how to represent a query in memory at runtime as a data structure. And it's a unified way. It's in the runtime. It's in the .NET framework. So you don't have to invent a new way of representing queries. All you have to do, which is what we do, is you take a URL, and what you do is we turn the URL into a LINQ expression tree, which, thankfully, very few people need to understand. Only the guys that implement LINQ providers have to deal with that. So what you do when you want to plug a service that is not a database is you need to go find a LINQ provider, or write one if you want to write one, and plug that into the data services runtime. Then what we will do is we'll look at the shape of that, build an EDM model out of it, so the interface looks exactly like the one that was handcrafted using the EDM, and then we'll expose the data. And when we have to pull data from the system, we will use the iQueryable interface, which is the interface to produce these query trees. Of course, that doesn't solve how to do updates. So what we did for updates is we have an extra interface that you can opt to implement if you want to have a read-write service. And at that point, you implement the semantics of what it means to, say, a post over something or a put over something and so on. So last point about this is I keep talking about the model. One of the nice things about being able to describe these services as a model is that then we can use model metadata to augment what the system does. And, or we can teach the system about specific aspects of the data that we are exposing. And I'll get to an example of this in a second. So let's create a couple of these services and see what they look like. What I have here is Visual Studio 2008. plus I'm going to call it the Astoria GUI, which you'll get very soon, which allows me to write Astoria-related things or data services-related things. So what I'll do is I'll create a new website. WebApp21 is a fine name, so we'll keep it. This will take a second. So we want to expose a data service. I'm going to start with a data service that has data that is not in a database. So I'm going to make a big simplifying assumption so we actually finish today and we don't miss the party, which is the data is in memory. But I'll point you exactly where you will get the data from somewhere else if it wasn't in memory. So the first thing I'll do is I'll go to my application, right-click on the project, and I'll add a new item. And in the new items list, you can see that there is a new guy here called ADO.NET Data Service. So we want one of those. And we're going to call this friends, which is a very Web 2.0 thing to do. Like you're supposed to have friends and links between friends and so on. So can you believe how many comments we put in this thing? Like we need to. It seemed so logical back then when we did it, but now every time we see it, we go like, wow. So we'll probably have less comments here. Like I can't think with them here, so I'm just going to get rid of them. So what do we want to do? First, we need to say what is the shape of the data we want to expose. We didn't want to cook up a new way of doing that. We already have CLR types that are self-describing, so we're using that. So we're going to create a class called person. Let's say my friends are all persons. And so a person is something that in my example will have an ID, which is made kind of databasey, but it may fly sometimes. Then it has a name that is a string. Maybe it has a date, time, birth date. And to make it sort of Web 2.0 compliant, we'll have a friend that is the list of friends for a particular guy, so we build a graph of friends. To do that, I'm going to say I have a list of person that are my friends. And this guy has a getter, and you're not supposed to set the thing, so I'm going to say private setter. So last thing I need to do is this list property I just created needs to be backed by an actual object, so I'll create a constructor here. And here I'll say friends equals new list of person. OK, so this is my data class. You're supposed to have a whole bunch of these. In this case, I have only one. By typing this class, I'm describing the shape of the thing I want. Of course, you can inject behavior in it as well and check whatever you're setting and all that. I'm skipping over that for the time being. Now, the last thing I need to do is I need to describe the service as a whole. Like, what does my data service look like? And we do that with a class as well. So I'm going to say public class. This is my friends data class. And again, nothing too fancy. All we say is, look, for every top level slash something, every top level entity set, what you do is you expose a property here of type iQueryable. Why iQueryable? Because iQueryables represent roots of query, or leaves rather, of query trees. So once you give us a base iQueryable object that represents a whole set, we can further customize the query by composing the query tree into a bigger tree and into a bigger tree and so on. And I'll get to an example in a second. In this case, I'm going to say public iQueryable of person. I'm going to call this actually people. What that means is when you go to the URL interface, you can say /people, and you'll get all of the entries in that container. But then if you say top one or order by something, or you say parentheses 1, 2, 3 and put a key, we don't need to bring all the data and then subset it. We can take the query object, compose the other operators like filters and sorts and so on, and then once we have a whole query tree, we execute it in one go. So we don't exchange extra data. We just tell the data source what the query looks like. We're literally building a query without knowing about it. And in particular, we're building a query that we have no clue how it gets executed on the next tier down, which is the whole point of doing it this way. So in this case, so this is the point where if you have a custom iQueryable implementation, say link to Active Directory, link to SharePoint, link to Amazon, whatever, what you do is you hook up your iQueryable implementation here. In this case, what I'll do is I'll use a feature of link that allows me to create iQueryables over in-memory data structures. So I'll just build literally a mock-up of a service, which, by the way, is a great way of getting started. If I want to write my tests first, what I can do is I mock up my service with in-memory data, get my test going, get maybe the rest of my application pieces, and then I can come back and build a real service. So I'm going to do that now. So we have person type. So I'm going to say there is an array of person. And we'll create 2 or 3 of these guys, new person, and then ID, 1, name, foo, birth date, new date, time, oops, something, say 1980, 1. So let's say we have like 3 of them. And we'll give them unique IDs because IDs is in the end what we use to tell them apart. And I kind of cheated here. We have an attribute that you can use to tell which member or members are the ID of the entity. But we allow you to say, look, if you own the objects and you can give them any shape you want, if you call the property ID, we'll just take that. So you get a cleaner object. So you can choose one or the other, whatever works for you. So I'm going to call this guy Bar and this guy Buzz. And let's say we're going to make this birth 81 and 82. OK, so here's our data. Last thing, we want to link some of these people together. So we're going to take the first person and take the friends, which, remember, it was just a list. And we're going to add the second guy and the third guy. So the first guy has 2 friends with it. So now we have an array, and what we want is an iQueryable. Link has this nice feature where whenever you have an IEnumerable, you can say ask queryable, and you get an iQueryable implementation for it. Of course, this is nice for mocking up data when you're maybe you're approaching your development using like a test-driven development approach. And it's also nice when maybe it's an XML file or something that you're going to anyway load the data in memory and do the processing in this computer. If it is a real database or a real data system where the queries happen remotely, you have to implement a real thing here. Otherwise, we'll pull all the data and process it in the client, which is bad. OK, we're done now. Now, what we need to do is we need to tell this guy what is the data service that is hosting it, which is what I'm doing by putting it here. So the last step was I'm defining the friends service as a data service on top of friends data. And now I can run this thing. And that's going to do not what I wanted. Close this and run it like that. If I go here and navigate to the friends.svc endpoint, what I see is nothing. So one of the interesting reactions that we saw last year is I did the same thing, just pointed to a database. And then I started to throw in URLs in the browser, and people started to transform their faces. It's like, great, you just wrote the fastest way to hack my database ever. So people are going to come party on my data. So of course, that was a prototype. We were just thinking about the problem. So by default, services are fully locked down. Like, you don't get to see anything. And what you have to do is you have to set the visibility rules for a particular service. In this case, I'm going to say config.setAccessRule. I have only one set called people. And I'm going to set the rights to all for the time being. Compile this guy. Now, if I go here and hit refresh, what I get is I get one set, people. And you'll notice that this service is, from the interface perspective, undistinguishable from the ones I've been using so far. Yet the data source is very different. So I have a people thing, which means here I can say /people. And I get, let's collapse this thing so we can see. I get 3 entries. And let's pick one of them. And I can see foo and 1980 and ID 1. I can, of course, drill into one of them. And I can see the actual entry, which also requires a query. Because in the end, what that means is, from the people set, write a filter predicate, like a where condition, that says, give me the one with ID 1. And I can also do traversal. Like, for example, here I can say friends. And we are going through the property. And now we have these 2 guys, which if I expand one of them, this is the guy bar ID 2, which is a friend of the ID with the guy with ID 1. So what you can see is I built a whole service, read-only so far, with in-memory data, completely different from the other one. But the interface is identical. So the model is the same. It's the same sort of entities and links type of model. And that's sort of a feature of the system is no matter where you pull the data from, it looks the same. And it's very flexible on how you pull the data into the system. OK, all that said, I like databases a lot. A lot of data is in databases. And there is a very broad set of scenarios which is about them. Also, databases are very well understood. So we can make it much easier and less sort of elaborate to build services on top of databases. Let me go do that. Close this guy. So I'm going to create a new service now, this time on top of a database. In fact, I'm going to use the bookmarks database, so then we can elaborate over that a little bit more. First thing I need is I need to bring my data into the application. To do that, I'm going to use the Entity Data Model Designer. Whoa. Ouch. Of course, now the computer is all confused about it. Who knows what's going on? We actually survived. Look at that. Let's see how many of that will actually go through. So what this does is I can point it to a database, and it will set up the AD.NET Entity Framework to create a conceptual model of my database that then I can tweak. It's an EDM schema layered on top of my database with a mapping in between. So I'm going to call this guy bookmarks, because I'm going to hit the bookmarks database. I'll choose generate from database because I already have a schema. I'm going to use that as a starting point. I'll point to my bookmarks database that I have here. And by the way, the thing at the bottom was take all of the configuration information and put it automatically in web.config so it's ready for when I deploy, I can go change my configuration. Now I need to choose my tables. I'll choose all of them for the time being. We'll talk about that in a minute. And I'm all set. Now what I have is what we call a conceptual model on top of the database. And the default mapping looks a lot like a relational schema, although already has some differences. For example, bookmarks and tags are a many-to-many association, which, of course, cannot be represented in a database. Typically, you have what we call a link table in between. Whereas here, we figured that out, and we actually turn it into a many-to-many relationship that you can see here. Here, since this is a conceptual model and it sits across a mapping from the database, I can tweak my model if I want. Sometimes I can do very substantial tweaks, reshape the data and such, or sometimes I can do cosmetic things. So I'm going to do the cosmetic side because it's faster. I'm going to call my sets in plural. Maybe tags should be more like tags. Let me pin this guy so we go faster. So I want this guy to be tags and this guy to be users. And also I want to tweak some associations. And you can see here the navigation properties have become associations on my model. So here I'm going to call this guy tags because I have multiple tags, and this guy bookmarks. And finally, this guy here, I'm going to call it bookmarks as well. OK, so we have a model. I'm going to change an option here and save this guy. So now we want to create a service on top of it. This time, we can avoid having to do all the generating classes and all that we did before, because I already have a model, and the system understands what it looks like. And we generate something that is already compatible with the data service. So all I need to do is I'm going to create a service. We need to survive the excessive comments shock. And this is not AdventureWorks. This is bookmarks. I'm going to call this guy bookmarks and kill all the comments quickly before we get distracted. And here, I'm going to add a using. And I already have a bookmarks model that was a namespace generated by the tool. And also, I have a bookmarks entities class. Let me remove this comment. That represents the database as a whole, or the model as a whole. And this is what I'm going to put here, bookmark entities. And this class follows the pattern I just described, so I don't have to do anything else. Of course, at this point, I'm not going to see anything just like before. So I'm going to use a demoware feature, which is say star, to say I mean all. Just don't do this at home. OK, so I'm going to come back here, say /bookmarks.svc, and we should have a bunch of bookmarks. This is the same database you saw a minute ago. It's not going to be very exciting. If I say /tags, for example, I will go. This is the first time we're hitting the database, and here the tags back. And same format and all of those details. So you can create what I just showed a minute ago by just going through these steps. It's pretty straightforward. Actually, let me show you one more thing. So one of the things I mentioned is about using metadata to drive what the service looks like and what it means. So let me show you a very small example of that. I have a link somewhere here. So within the bookmarks, I picked up a particular bookmark. And I looked at the description of that bookmark. And this is the guy. So you can look at this bookmark. This is a long description of it. And it actually has markup in it. Okay, it has an H1 there, like a heading. If I go /$value, which we talked about it before, it looks like text. The reason why it looks like text is because I didn't say anything about it. So by default, we display it as text, which is a pretty safe choice, except when it looks like a binary value in the input, and then we send it back as an octet stream. That's the only exception. Other than that, we always send text. But I may know that this is something else. Like in this case, I clearly know this is HTML, although it's not. It's just a fragment. But let's pretend it's whole HTML. What if I wanted to tell the system that? We can do that with metadata. So I'm going to go open this guy here. Actually, I'll go to the XML view. There is a bunch of XML here. Don't worry. Usually it's OK. I survived so far, so it's probably fine. So I want to do two things. One is I want to add a namespace so I can customize stuff. I want to add the data services namespace. I'm going to grab this guy and put it in my document somewhere, say here. There. So namespace name is DS. So now what I want to do is I want to find the bookmark entity type, which is this guy here. Hopefully you never have to deal with this XML, but I want to show you the details. And this particular trick you can't do with the tool. So I found a long description property, and what I want to do is I want to add an attribute here, so I'll add it at the end. I'll say data service MIME type equals, and in this case I'm going to say text/HTML. So let me open this in the designer, so I make sure this gets code genned and compile this again. So now, whenever you request that piece of information, we know that it's supposed to be HTML, so the content type that we attach to the response is the one you told us. So when you hit this thing, now the thing becomes proper markup because the client agent understands the representation that we're sending on the way to the client. That means you can serve pictures, you can serve HTML, you can serve whatever you want. More interesting, you know how difficult it is to upload like a picture to a database? It's a lot of pain. There is the debate of whether you should put them there or not, but I'm not going to get into that. Same thing with HTML or pretty much anything that is not a little string. Well, this is regular HTTP interface. That means that you can use any command line client, like curl, for example, or anything you want, to do an HTTP put or post to push one of these values into the system. So if you have an image, you can literally copy it over HTTP, and you're actually putting it in the service. All right. So one of the biggest pieces of feedback that we got last year when we started to talk about this concept and we were exploring how people would use it was, well, that looks great. You have to tweak the little security problem I mentioned before where we expose everything by default, which was by design. It was a prototype. But besides that, there was a problem of overall, how do you build an application? Very rarely, an application consists of a bunch of data that anybody can go and do whatever they want. It's not very interesting. So there is a number of aspects that have to do with how you build an application, how do you expose behaviors, and how do you choose who sees what data. So we introduced a set of features that work together to enable scenarios where you want to build an application, but the service itself makes sense in isolation, meaning with the application on top or without it, the interaction model with the service is reasonable and it shows what it needs to show and it doesn't show what it doesn't need to show, and it behaves as it is supposed to behave. So there is a collection of features that work together for that. Let me scan through them. First one is visibility. You want to be able to say what containers of data are visible and which ones are not. And for those that are visible, what are the legal operations of them? Like, can you do gets? Can you do puts? Can you do posts? Is it OK to query over them? Open query is OK over a huge container? Or maybe you want to only address a particular item on one of them? All of those questions need to be addressed. And since these are cross-cutting concerns, we have to do it in a way that looks like policy more than a procedural way. We cannot call you every time one of these things happen. So it's switching back and forth because a lot of these things are much easier by example. So what I'll do here is, let me show you this service. This service has an interesting bit that I sort of ignored so far. If you look at the root, which gives you an Atom service document that is handy here, you can see what are the top-level containers. There is bookmarks, makes sense, you want your bookmarks. There is tags, makes sense too, you want your tags to be public. There is users. We'll come back to this one in a second, but you definitely want to address users, so that makes sense. And there is user authorization info, which I didn't drill into, but what sits there is like the password hash and all that stuff. Definitely not the right thing to have there. But the problem is, I want it in my model because on the server, I use it. I use it to write queries, I use it to write my business logic, and so on. It's just that I don't want it in the model, on the interface. So what I'll do here is, I'll write this as you're supposed to write it. And I'm going to say, bookmarks, OK, just allow all of the accesses to bookmarks. Actually, you have one too many there. Then there is tags, same thing, allow all access to tags. Now there is users. What I want with users is, I want to be able to address a particular user, but there is no reason why you should be browsing users. You should be able to address your user, but nothing else. So I'll do half of this here and half of this later. The half that is here is, I'm going to say, what you can do is, you can read singles. Meaning, if you have a URL that lands you on a particular user, that's OK. What you cannot do is browse. You cannot query. You cannot scan the table or stuff like that. So if I compile this guy and come back to the service document, now the auth info that was back here now is gone. It's not only gone from here. It's gone from the metadata. It's gone from any associations, any reference to it. It's completely gone from the system. So it does not exist from the interface perspective. So that was the first piece we got feedback about. Second aspect, authentication. What do you do about authentication? So one of the things that you don't want to do is invent an authentication scheme. Definitely not a good idea. So what we do is we looked at what are the runtime environments we run inside. We run inside ASP.NET. We run inside WCF custom hosts, Windows Communication Foundation custom hosts, or we have an interface to custom host the runtime anywhere you want. In all cases, there is always a runtime environment around us. So what we do is we just make sure we're not in the way, and we let you use the authentication mechanisms in the runtime environment. So for example, you can use ASP.NET Forms authentication, which should be called more like cookies authentication. You can use BASIC or NTLM, or you can use one of the WCF fancy authentication schemes that are, many of them are pre-built into the system. So I'm not going to drill into the examples, mostly because I'm running out of time, but there is a talk on Friday called Real World Applications with RESTful Data Services. That's very far from the real name, but you'll just look for the words and you'll find it, that Mike Flasco is doing, that he'll drill a lot into the details of how to actually implement it. But bottom line is we count on the environment to give us authentication protection, and then authentication information. So next thing is interceptors. One of the tricky aspects is, sure, you can use the policies that I talked about before to filter which containers as a whole you can see or not see, but that's not typically enough. The problem is you need to choose which data at the instance level you can see or not see. And for that, we have a mechanism called interceptors that allows you to customize a lot of how the service behaves and what data goes through the service or not. And this last thing I'll show before I run out of time. So let's talk about users first. So users are interesting in the sense that if you look at the interface here, I cannot say all the users. If I say /users, I get a forbidden request. Of course, in the real final bits, you're not going to get the stack trace out of it. But if I point to a particular user, I do get it back. What I cannot do is browse. And if I point to any user, I keep getting it back, which doesn't make sense. I should get only my user, whatever that means. So let me write an interceptor for that. Since I need an authentication function, for now I'm going to have a function called getID, and I'm going to return 1 as my user ID. So you can imagine that what you do here is you check, HTTP context or actually like thread.currentPrincipal or service context whatever is the authentication property or so on. You pick up the authentication from the environment. And now let's write a query interceptor for this guy. So I'm going to say query interceptor of users. Oops. And what we do here is we let you describe a filter predicate that we further compose into the query. The nice thing about this is, since it is also based on query composition, this is not something that happens after the query executed in the middle tier. This gets pushed down along with the query into the data source, being a database or whatever. So what we need to return is an expression. So here I'm going to add link.expressions. And here what I'll do is I'll return an expression of function of, this is a function that goes from a user object into a Boolean condition, okay? And it's an expression because I don't want a delegate that is going to be evaluated for every row. I want an expression that represents the condition, and then I can use to formulate my final query. I'm going to call this onQueryUsers. And the way we want to handle this is we want to say int user ID equals get ID, which of course is supposed to be more interesting than this. And once we have the ID, we can filter, for example, in this case, I can say return, given a user, I'm going to use the new features in C#, in this case, this is a Lambda expression, that says user.id equals user ID. So here, that's a predicate that is going to be injected over any of the queries that I do to users, regardless of how I land there, top level /users or through some navigation or something. Since the expression there is completely independent from the context, we can inject this anytime you mention users. So it's a very general mechanism to do instance level security or row level security at the service endpoint level. So let's build this guy and try it again. So I hard-coded the ID 1. So if I do 1, I get the user back. Now if I do 2, I get 404. Like, the thing doesn't exist, actually. Again, you're not going to see the stack trace. And the same thing happens with sets. If you have a predicate that says, I want to see the bookmarks from the users with ID whatever, then you will get the subset that actually applies to that particular user. And just like we have query interceptors, like the one here, we have update interceptors that allows you to run code in the opposite direction, on put or post or delete. So you can implement business logic, validation, and even in this case, you can check that you can only modify your own user, for example. OK. Whoa, it's shaky again. So the last item I wanted, so actually before I move to service operations, the one thing I really like about interceptors is it allows you to inject behavior, instance level filtering, checks in general, in update you get to run code and so on. But at the same time, they preserve the resource-centric interface intact. It doesn't look like operations. It's semantics layered by you on top of the base system, but retaining the basic interaction model that comes with the RESTful architecture. So I thought it was very nice result out of the thing. And this has been evolving over time. And I think with all of the feedback that we got and so on, we landed on a nice place. Oops. One more thing I wanted to talk about is service operations. So this REST thing is very nice, but like I don't want to be sort of hardcore closed about if it is not REST, we're not going to do it or something like that. There is a practicalities of building real applications where you can get sometimes 99% there, and then you have this one thing that doesn't make any sense in a particular model. And this happens on any generalization that you try to use. So we have a way of saying, if for this one thing you can't use the uniform interface, that's fine. You can just create a method. And we will inject the method into the URL space. Like, for example, here you can define a method called myTags, like the example at the bottom. And when you say /myTags, what we do is we just call your method. The nice thing is you still can return a query if you want. So that means you can still do paging and sorting and all that, which we'll do on top. And if you don't want to do that, then you return an IEnumerable, which is not composable. And then we don't do that. It's a fixed result set. All right. So to wrap up, I wanted to mention a couple of concrete application scenarios. One concrete one is Ajax integration. A lot of applications, modern applications today are built on Ajax. And it turns out that the combination of an HTTP interface plus the JSON format actually works really well in Ajax. So you just saw a little grid. We also have an Ajax little API, like a library that we're going to ship at some point, probably a little bit later, that you can use to interact very easily with the service. You can use just plain XML HTTP if you want, but this makes it a little bit nicer to interact with the model. Of course, the fashionable thing to do now is to build Silverlight applications, Silverlight 2 applications in particular. And for that, we have full-on Silverlight application support. We have a runtime library, our API, that allows you to see a data service in terms of objects. So you get .NET objects that you can use to represent the results of a query. And also, we do automatic change tracking. Like, you have to tell us whenever you change something, but we then do the application for you. So you can send a URL, get objects back, manipulate the objects in memory, and then once you're done, you can tell the system to push the changes back to the data service, and we'll scan the things and send all of the HTTP operations. Furthermore, writing URLs is OK, but once you're in the .NET environment, you actually want to write link queries. Well, because we already solved that problem. Now we have syntax highlighting and like checks for correct syntax and correct semantics, like member names exist and types are correct and so on. So we actually have a link translator that will take link expressions and turn them into URLs. So you get the nice thing about link, but you sacrifice nothing on the wire, because what we send to the server is actually a URL and nothing else. So you can write, I'll just show you. I'm not going to run it because I don't have any more time, but I can't help showing it to you, at least. Come on, here. So this is an actual Silverlight thing. I'm not going to run it, but I want to show you this one thing. So this is what the world looks like. This is a full, just HTTP-only thing with nothing else around. Yet, what you see here is full objects. So you create a service object that represents your session. It's not a session, but your entry point to the service, and you give it the URL of what you want to talk to. And then if you want to write a link query, here you go. This is a link query. And we don't have any more time now, but if you stop by the the open space during the conference, or you come to the two sessions we have on Friday, we'll show this working. We literally translate this into a URL, execute it, and then gives you a bunch of objects back. So you stay entirely in the context of the .NET framework when you're working with objects. And of course, there is a lot of web applications out there being built, and they will want to consume data from other services out there. So for that also, we have nice integration. The same API that I just showed runs on the server, so you can use it in ASP.NET. And we also have ASP.NET data source control that allows you to use all of the UI controls and bind them to this, just like you will have bound it to a SQL data source or an XML data source. So you get to consume services from out there on the web. And the same .NET client, of course, runs on the desktop, so you can build WPF applications and fancy UIs and all that. So with 30 seconds, according to this thing here. So where we are today, and I have this slide and one more I wanted to go through. Where we are today is we turned from prototype to real deal. We got your feedback. It was positive, so we went for it. We will ship beta 1 in a few weeks. We actually managed to sneak in just a current build, very low expectations, on the CD, so it's in the MIX CD. No setup, nothing, just the DLLs, very raw. But if you are desperate for checking it out, then you can pick it up there. If you wait a few weeks, you will get the nice package and all that. And we're thinking of RTMing the product around mid-year, give or take. So in summary, this framework allows you to create services and consume services that are data-centric and use the RESTful architecture style. And there is an opportunity here, and we'll talk a lot more about this on Friday in the 2 sessions I have at the end of slide deck. There is a huge opportunity to unify interfaces and leverage unified tools, unified components, unified UIs, and so on across all of these services. So you should give it a try. Last thought, and I promise I'll let you guys go after this. So last year we said we're thinking about this, and we got good feedback, so we did it. So we're thinking about something else, and I wanted to share it with you before I leave. And based on the feedback, we'll see what we do next year. So this is great so far, but it's online. Connection goes away, you're stuck. There's nothing. There's no HTTP magic. There's nothing we can do about it. So what if we could do something like this? You're in Visual Studio, and I'm totally hand-waving over this. We have a demo. You should go see it, but it's hand-waving. So you're in Visual Studio, and you want to build an application that uses the service, but it works without connection. So what you do is, in Visual Studio, you right-click something, and you point it to a service. And instead of saying that you want a reference to a service, you say, I want to take the service offline. So what we do is we create a local SQL-C database for you. We copy the schema. We have the metadata, so we replicate it locally. We set up a replication profile, at least a default synchronization profile. And then you write a local application. Then we have enough there to do syncing on the background. So now you write a local application, and then you sync on the background. So you can have a nice sort of Outlook-style applications against services out there that support the sync interface. Just a thought. If you're interested in the topic, come talk to us. It's very early. We have a prototype. We'll show it on Friday. We'll see what you guys think. So with that, there's a couple of slides here with related content. You should check it out. Highly recommend these sessions. And I know I went 2 minutes over time. I appreciate you sticking around. I'll take questions here in the open space, and I want to thank you very much for coming today.